we try to understand what kind of solutions we need for your Kubernetes applications. So I'm here trying to talk about there are the various kind of application you run into the Kubernetes state. Some of them are stateless app, like just like a web page, where you make changes less often, and most of the time you make changes through your uh, source control, like GitHub. So you can manage the revision of those applications into the YAMLs. But if these are the large applications and you have so many teams working on these applications, managing all the revision control and going to the known good state sometimes can become a tedious task. But still you can manage a lot of protection needs through YAMLs in your source control. However, more and more enterprise ready application for production workloads like databases and all, they store data into a persistent volume, which is your kind of storage. And you would need a proper backup and replication software to manage those Kubernetes resources and persistent volumes across these applications. And another kind of applications, they are not storing data onto the persistent volumes or onto the storage. However, they still store state into the Kubernetes CRDs. For example, nginx is storing a lot of load balancer and security keys and all information into the config map as well as in the secrets. So those are the Kubernetes resources stored into the Kubernetes database, needs to be backed up and replicated, and they are not into your source control repository. So in this case, you would also need it. So most of the time, you would need enterprise would need a data protection solution in most of the scenarios, especially if the application is involving the multiple teams and also deployed across the multiple clusters. So what are the criteria of choosing the right solutions for a data protection? So the first thing you should look at, like, what are the flexibilities provided with my data protection solutions? And as the Kubernetes is a multi-tenant aware already, it has two kind of tenancy model. So one of the tenancy model where a lot of people use the namespace is a tenancy model. So in the single cluster, you have a many namespaces. But also there are tenancy models like you create for a cluster for every applications. But most popular one is the namespace based tenancy model. And in that case, the operations team who is managing the Kubernetes platform may not be aware of all those application teams, would need a solution which can allow to take maybe the backup of whole environment or full cluster, however, able to restore a specific application uh, through a namespace. Or even a backup is only the applications which are critical in the cluster, and skip the application which are not critical. So you need a lot of flexibility in the solution which can back up at very different granularity level, and supports a different kind of tenancy model without knowing those application teams and their application structures in reality. The second most important part is the data. As you're running a stateful application, you may be running a lot of application with data on some storage, and some of the times the storage may be durable storage, where if storage crashes, it has availability zone, and then you can bring back. In some of the times, your storage may not be durable, so you may need to choose a solution which can help to protect that data. If your storage is durable, you can use a snapshot approach. So you can keep copying a snapshot. But if your storage is not durable, you need some kind of a solution which can copy data to alternate storage, probably a kind of file system backup methodology. So stateful workload may have both kind of needs, and you may have to choose a solution which can handle both kind of storage challenges with the durable and non-durable. For example, if you use empty dir is kind of on the cluster volume, which is not durable, and then you may need to sometimes store data because it may have some state of application which is required to come back the application uh, perfectly. Another critical aspect is about the workload mobility. So most of the time, when you kind of take a backup, uh, you may lose your hardware infrastructure, or you may lose your site, and you have to restore the application to a different platform or different even cloud provider. So does the solution helps you to move application across the cloud platforms providers, or even sometime across the Kubernetes versions. So you need a solution which can help with the workload mobility. The third is a multi-cloud support that's linked with the uh, uh, ability to restore application to a different platform. However, it's not only important that you support the various cloud providers for the Kubernetes. You also need to look at when you back up your data, you may be backing up into durable storage, which is your backup storage location. The solution should be providing not only the different Kubernetes provider as well as a different backup storage providers as well. For example, can I back up my storage into the AWS S3 bucket? Can I back up my data into the Azure Blob storage or my on-premise uh, storage? So you may have a need where you have a broad platform support both for Kubernetes clusters like your on-premise Kubernetes deployment or your cloud Kubernetes deployment like EKS or AKS or other solutions. So you need flexibility on the both side for broad platform support. Also, you need to make sure that it is built on some kind of open standards that will help you not to be in the vendor locking. Uh, and open standards also help to extend the solution in future. For example, as a Kubernetes is maturing in the storage solution space, and you may be aware there are new concept of container storage interface, which allow you to create a storage plugin for Kubernetes. And new all the vendors are not there. Some of the vendors have that CSI driver. Some of the vendors are still building. So your backup solution should able to provide to extend the backup solution with the upcoming new storage vendors and upcoming new storage plugins. So if the backup solution provide a way in which you can plug in your new storage vendor for backing up their storage snapshot or taking or backing up data onto their storage, that would help to kind of make more flexible plan and move your backup storage platform from one vendor to other vendor as well as if the solution is built using a Kubernetes native way, cloud native way, then you will also have easy way to kind of use the backup across the various different solutions as well. So application can be cloud native and then built on the cloud native standards. So these are the some of those areas in which we should be focusing while choosing a right solution.